Hello my dear students, welcome to IMS GATE Academy excellent practice question series on communication subject. So in the previous sessions we have discussed various questions regarding amplitude modulation and DSB-SC. Those who are attending very first time regarding this particular session, so kindly watch those sessions in your free time. So we have discussed variety of gate questions and practice questions related to amplitude modulation and DSB-SC. So in this particular session we will continue further regarding DSB-SC further questions. Okay. And this topic is also common for two branches, EC and instrumentation. So kindly share this video link with all of your friends so that they also will attend this session live and they also will get benefited from this particular session. So I hope all of you will quickly share this video link with all of your friends. Yeah, this is the MSQ question. So that means either one option or more than one option can be correct. So this is the question related to DSBSC. So all of you kindly read the question and choose all the possible correct options. Whichever options are correct, you have to choose all the correct options. Yeah. So here you are having multiplier. So here you are having two inputs, X and Y, and here X is nothing but message signal or modulating signal M of t, and Y is nothing but carrier signal C of t. And after multiplying these two signals, we are getting the output that is nothing but S of t. So read the question. You are having one multiplier. Here this multiplier is nothing but balanced modulator. Okay. So here you are having physical circuit that is nothing but balanced modulator. Okay, balanced modulator circuit will produce the DSB-SC signal. Okay, but here regarding the DSB-SC standard equation is nothing but just the product of message signal and the carrier signal. That is the reason sometimes you will be having regarding the DSB-SC, in order to produce, you can have the balanced modulator or product modulator or simply multiplier. Okay, all are same. Okay, so whichever circuit is producing DSBSC signal, that particular circuit, if you want in simple words, you can just consider like multiplier or product modulator. Okay, right. Here the input terminals m of t, it is mentioned like 6 sine 2 pi into 1200 t and carrier signal 6 sine 2 pi into 12,000 t. And here regarding this particular multiplier output, you are getting the DSBSC signal. In that particular signal, what are the frequencies that you are having? That is the question. What are the frequencies this particular S of t signal you are having in the order of kilohertz? So here you are having 4 choices. Whichever options are correct, you can choose. Right. So regarding message signal and carrier signal, what are the equations they have given or expressions, okay, that I have copied here. Now S of t is nothing but, just for understanding, for one case I will explain here, okay, but once if you understand the overall phenomena, okay, from next question onwards, without doing like this calculation, directly we can write what of t is nothing but message signal and carrier signal, just you have to multiply. You can write m of t into c of t, or you can write c of t into m of t, no problem. In any order you can represent c of t into m of t. Now regarding carrier signal, you are having 6 sine 2 pi into 12,000 t, 2 pi into 12,000 t, and here you are having regarding message signal, you are having 6 sine 2 pi into 1200 t, 2 pi into 1200 t. Okay, right. So here if you observe, 6 is there, 6 is there. When you are multiplying, you will get 36. But for the time being, I will write that one like 6 into 6, you are getting 36. So that 36 you can write as 18 into 2. Why I am writing like this, you can easily understand. Okay, for the time being, I am writing 18 here. After that, you are having 2 sin A sin B format. 2 sin A sin B format. Yes or no? So regarding that, we have already discussed in the earlier sessions also regarding this trigonometric equation. 2 sin A sin B is equal to 2 sin A sin B is equal to cos difference minus cos sum. Cos difference minus cos sum. 2 sin A sin B is equal to cos difference minus cos sum. Okay, that is the reason I have represented 36 as 18 into 2. Okay, 18 I have written here. Now whatever the expression here you are having, it is like 2 sin A sin B format. Now you can consider cos of A minus B minus cos of A plus B. So here cos A minus B. So 2 pi if you take common, 12,000 minus 1200. 12,000 minus 1200 into t. Okay. 2 sin A sin B is equal to cos difference minus cos sum. Cos sum. 2 pi into 12,000 cos difference minus cos sum. 12,000 plus 1200 into t. So here 18 into cos 2 pi into here 12,000 minus 1200. So here 1200 plus 800, you will get 2000. 1200 plus 800 is 2000, but here you are having 10,000, right? So total 12,000 is there, so that means you will get 10,800. So you can observe 10,800 plus 200, that is 11,000. 11,000 plus 1,000 is nothing but 12,000. Next, minus cos 2 pi. here we have to add both 12,000 plus 1,200. So that means you will get 13,200. 13,200. So now if you observe, here you are getting two terms. You are getting two terms and both are related to cos. Okay, right. So you may get cos or you may get sin, no problem at all. But you can observe the standard format, cos 2 pi ft, cos 2 pi ft. Similarly here cos 2 pi ft. So that means now if you observe, you are having one frequency from here and one frequency from here, and if you observe these two frequencies are not same, right? Here you are having one frequency 10,800 Hz and here you are having another frequency 13,200 Hz, right? So this particular S of t signal we are having two frequencies. S of t signal we are having two frequencies. One is 10,800 Hz, 10,800 Hz. So in the question it is asked that in the order of kilohertz, right? So this one we can write as 10.8 kilohertz. 10.8 kilohertz. That is the first frequency. And other frequency we are having 13,200 Hz. 13,200 Hz. In the order of kilohertz, we can write it as 13.2 kilohertz. 13.2 kilohertz. So that means we are getting two frequencies, 10.8 and 13.2. Now you can observe 10.8, yes, we are getting, and then 13.2. So option A and option B, both are the correct answers. Option A, option B, both are correct. So the final answer for this question is option A and option B. Okay. Now just observe this entire simplification and what is your final observation point. All of you please observe this entire derivation and what are the final answers we are getting. Okay, and from the original equations, what is your observation point? So if you have observed few points, okay, this is the conclusion point, okay, that conclusion point if you apply, you can easily solve any question related to DSBSC easily, okay. No need to derive like this simplification, no need to do each and every time, okay. Here for understanding purpose, for one question I have done the simplification step by step, but whatever the conclusion points we got, directly whatever the frequencies here finally we got, okay, directly you can represent. How easily we can represent, you can observe. Here you are having message signal, right? Message signal you are having. So regarding message signal, you are having one frequency. That frequency is what? FM for generalized case. Okay, in this particular example, it is 1200 Hz. 1200 Hz. In this particular example, it is 1200 Hz. Okay, since the question they are asking in the order of kilohertz, so just convert into in the order of kilohertz. So you will get 1.2 kilohertz. 1.2 kilohertz. Right. Now you are having one more signal, that is a carrier signal. You are having carrier signal. So it is also having some frequency, that is FC. For generalized case, it is FC. Carrier frequency. This is the message signal frequency or modulating signal frequency. In this particular example, it is given that 12,000 Hz, 12,000 Hz, 12,000 Hz. So in the order of kilohertz, if you are writing, this is 12 kilohertz. So here regarding regarding DSBSC signal, we have to multiply the carrier signal and message signal. We have to multiply the carrier signal and message signal. Okay. Now if you observe here, here in this particular example, both are sine signals. Both are sine. Okay. So when you have applied this formula 2 sin A sin B, you are getting like cos difference minus cos sum. Cos difference minus cos sum. So that means here whatever the two frequencies here you are having, okay, that difference we are considering in one of the term. Right, and in another term we are just performing the addition, that's all. Okay, so that means whether you can have sine or you can have cos, etc. No problem. Whatever the four possible trigonometric equations you are having, from there you will get in one of the term difference, in another term addition. Okay, right, according to the formulas. Okay, like 2 sin A sin B, or 2 sin A cos B, or 2 cos A sin B, or 2 cos A cos B. Okay, you will be having 4 equations, right? Now regarding the DSB-SC signal, whenever you are having DSB-SC signal, in the time domain we are multiplying. The modulating signal and the carrier signal. But coming to the frequency, when you have represented the same DSB-SC signal in the frequency spectrum, okay, there you are getting 2 frequencies. Whenever the modulating signal, when it is having one frequency, and similarly when the carrier signal is having one frequency. So when you have represented the DSB-SC signal in the frequency spectrum, you will get 2 frequencies. One is addition of these 2 frequencies. Okay, so that means FC plus FM, that is one frequency you will get. Another one is FC minus FM. So here you can observe, regarding FM, in general always the modulating signal or message signal frequency will be less when compared to the carrier frequency in general, right? Okay, that's why here you can observe, regarding addition there is no problem. When you are performing addition there is no problem, but when you are subtracting, you can subtract the smaller from larger, because here ultimately what you are going to get? Frequency. So frequency can never be negative, right? So frequency should be always positive. But whenever we are drawing the spectrum in the frequency domain, just for symmetrical purpose, okay, we used to represent on negative frequency side, but theoretically negative frequency never exists, right? Practically negative frequency never exists. Only for theoretical purpose, just for graphical representation, we used to represent minus f. Okay, just like positive x-axis if you are having, similarly you will be having negative x-axis, only for symmetrical purpose. Okay, whatever the diagram that you are going to get in the positive side, positive frequency side, similar diagram you will get negative frequency side, only for graphical representation. Theoretically when you are drawing on the book, okay, only for symmetry purpose, we used to, sometimes we may represent minus frequency, right, or negative frequency axis, but practically or physically frequency never be negative, right? Frequency always should be positive, correct? Right. So that's why whenever you are doing the subtraction, okay, that is the reason here also if you observe why I have represented the carrier signal first and then message signal here. Okay, instead of that, if you have considered message signal here and carrier signal here, then when you have applied this formula, okay, you will come the situation that 1200 minus 12,000. In this expression you will get like 1200 minus 12,000, right? But here when you are subtracting, you will get negative. But here you are having what? Cos signal. Cos of minus theta is nothing but cos theta. It is even function. So that is the reason. Even if you are getting minus because of cos signal, ultimately you are getting that cos of minus theta is cos theta. That's why, just to make the simplification easy, okay, I have considered the C of t first and then message signal. I hope it is clear for everyone. Now this is the conclusion point. Whenever you are having DSBSC signal, it is having 2 frequencies, okay, FC plus FM, okay, and another frequency is FC minus FM. So when you look at these 2 frequencies, this is larger when compared this one. So that means this FC plus FM is nothing but what? Your upper sideband frequency, and FC minus FM is nothing but lower sideband frequency. Okay, here carrier frequency is the like center. Okay, from FC towards right hand side, you are getting FC plus FM, that is nothing but upper sideband. From FC towards left hand side, you are having FC minus FM, right? So that means here in the DSB-SC signal, if you observe, you are having double sideband. That means you are having upper sideband and you are having lower sideband, but there is no carrier frequency component. That means at carrier frequency, when you have drawn the spectrum, okay, on frequency axis, at carrier frequency, so in this example carrier frequency is 12 kHz, at that particular frequency the signal strength is 0. Okay, that is the reason here the name of this particular modulation is double sideband suppressed carrier. Carrier was completely suppressed. Okay, I hope it is clear for everyone. Now just you can perform the addition and you can perform the subtraction, that's all. 12k plus 1.2k, so that is nothing but 13.2 kilohertz plus 2, 11 plus 1 is 12 kilohertz. Now tell me how much time it will take for solving this given question. This is the method 2. Whatever we have discussed earlier, that is the method 1, but from method 1 only, if you observe carefully, whatever the another method we have discussed, that is the direct step. Just tell me how much time it is required for solving this question. It won't take much time, yes or no? Hardly. Whatever the calculation required, all the calculation you can do without using pen and paper, yes or no? Just you have to observe the frequencies of both the signals, and just you have to perform addition, just you have to perform subtraction, that's all, right? When you are subtracting, you can subtract smaller frequency from the larger, that's all. Okay, all the calculation you can do in the mind only, right? You no need of any pen and paper, yes or no? Okay, that much easy. You can easily solve DSBSC signals easily. Okay, right? I hope it is clear for everyone. For understanding purpose, I have discussed the mathematical derivation, but you can follow this method for solving any DSBSC question. Okay, I hope it is clear for everyone. I am giving simple conclusion point. Whatever the modulating signal, whatever the carrier signal you are having, each and every signal will be having corresponding frequency, right? Whatever the frequencies you are having, you have to add, and whatever the frequencies you are having, you have to subtract, that's all. Okay, so those two frequencies you are going to get, right? So all of you give a try. Next question. This is the question asked in EC branch in the year 1999 for 1 mark. So here in this question it is mentioned that modulated signal, but they haven't mentioned which type of modulation it is happened. Okay, but they have given regarding that this particular equation, they have given the hint. Directly they haven't mentioned whether it is AM signal or DSB or SSB. Okay, they haven't mentioned, but they have given the clue. What is the signal you are having here? That is the modulated signal. Okay, now just observe this signal. You are having m1 of t cos 2 pi f ct plus m2 of t sin 2 pi f ct. Okay, right. So previously if you observe what we have told regarding DSB signal, you are having the message signal, you are having the carrier signal, we have to just multiply, that's all. Okay, here in this particular example, message signal is having one frequency, carrier signal it is having the corresponding frequency, right? Now if you look at this particular expression, okay, suppose if the second term is not there, okay, when you look at only the first term, okay, so this is nothing but your DSBSC. And similarly, if first term is not there, if only this second term is there, that is also DSBSC, right? Yes or no? See, regarding carrier, sometimes I can use cos signal, sometimes sin signal, no problem. Even regarding message signal also, sometimes sin signal, sometimes cos signal, okay, right? So individually if you observe, like this is one DSBS signal, this is another DSBS signal, okay, right? Now just continue further reading. From there you will come to know what is the given modulated signal. Okay, you can observe here, you are having here regarding m1 of t and m2 of t, it is mentioned that baseband signals. Baseband means whatever the signal spectrum you are having that is centered around origin, or you can say zero frequency, centered around zero frequency, right? And it is having regarding m1 of t, the bandwidth is 10 kHz, and regarding m2 of t, the bandwidth is 15 kHz. Okay, so here whatever the bandwidth they have mentioned, okay, that bandwidth starting from where? 0. Starting from 0. Okay, so in the first example, it is mentioned that suppose bandwidth they have mentioned 10 kHz, so that is nothing but your FM1 only. FM1. So 10 kHz. Similarly, second signal 15 kHz, FM2, 15 kHz. Okay. Now when you look at regarding the message signal, okay, regarding the message signal, if you observe, m1 of t is having the frequency 10 kHz and m2 of t is having the frequency 15 kHz. That means regarding the modulating signal, we are having two frequencies. One is FM1, another one is FM2. And regarding the carrier signal, we are having only one frequency, FC, right? So whatever the example that we have discussed earlier, in that particular example, regarding the modulating signal, we are having only one frequency. So that means this particular modulation is nothing but single tone modulation regarding DSBSC. Whereas here we are having regarding modulating signal, we are having two frequencies, right? Whenever you are having two frequencies or more than that, regarding the modulating signal, if you are using any modulation technique, that particular modulation we will put the name as multi-tone, because it is having multiple frequencies, that's all. Okay, so that means now if you observe this standard equation which they have given in this particular question, that is nothing but multi-tone DSBSC, right? So regarding this particular signal, you are supposed to calculate the bandwidth. Bandwidth of the modulated signal in the order of kilohertz. Okay, right. So for easy understanding, whatever the given expression is there, for the timing I am writing like this. You are having two terms, right? So for the timing I am representing like S1 of t plus S2 of t for easy understanding. Okay, right. So regarding here S1 of t is nothing but the first term, that is m1 of t into cos 2 pi f ct. m1 of t into cos 2 pi f ct. Similarly, regarding the second term, that is S2 of t, which is nothing but m2 of t into sin 2 pi f ct. Cos 2 pi f ct, there sin 2 pi f ct. Okay, right. Now, when you have observed individual terms, those are nothing but individual DSBSC, right? So, regarding DSBSC, we already mentioned that DSBSC signal will be having two frequencies, right? So, here regarding M1 of t, the corresponding frequency is FM1. Here it is mentioned 10 kHz. FM1 is 10 kHz. And regarding the carrier frequency, it is 15 kHz. Carrier frequency 15 kHz. 15 kHz. So, here also carrier frequency is same 15 kHz. Regarding carrier frequency it is same. Now, regarding the M2 of t, the corresponding frequency, here you are having 15 kHz. Sorry, just 1 second. Yeah, FC they haven't given. Okay. So, here it is FC only. Sorry, just 1 second. So, in this particular signal, in this particular question, they haven't mentioned the FC value. Okay, FC we will consider as it is. Okay, in this particular signal, only in this particular question, they have given only regarding the modulating signals. Okay, regarding the modulating signal, it is having two frequency. M1 of t is having the frequency 10 kHz, and M2 of t is having the frequency 15 kHz. Okay, regarding the carrier frequency, in this particular question, they haven't mentioned, because in this particular question, regarding the carrier frequency value is not at all required. Okay, even without using the carrier frequency value, okay, you can get the final answer. That is the reason they haven't mentioned. And sometime, whether it is required or not, irrespective of that, sometime they will give the carrier frequency as like 1 MHz or 2 MHz, etc. Okay, right. But in this question, the carrier frequency value is not at all required. That is the reason they haven't mentioned the carrier frequency value. Okay, right. So, regarding M1 of t, the corresponding frequency is 10 kHz, and similarly regarding M2 of t, the corresponding frequency is 15 kHz. 15 kHz. Now when you look at this particular signal, it is a DSBSC. Similarly, this is also DSBSC. Okay. So, here you will get two frequencies. That is, first frequency is nothing but addition of these two frequencies, right? So, FC plus FM1. FC plus FM1. So, from here you will get FC plus 10 kHz. FC plus 10 kHz. Now, another frequency you will get, that is the difference of two frequencies. So, always the carrier frequency will be very high when compared to the modulating signal frequency, right? That is the reason I have considered like this, FC minus FM1. So, from here you will get FC minus 10 kHz. Similarly, here also you will get similar frequencies. Similarly, you will get two frequencies, FC plus FM2, and other one is FC minus FM2. Addition of two frequencies and subtraction of two frequencies. Here FC plus 15 kHz, FC plus 15 kHz, and other one is FC minus 15 kHz. Okay, now what is your observation point? Whatever the original signal you are having regarding message signal, okay, whatever the frequencies that you are having that are nearby zero frequency, nearer to zero frequency. Okay, here you are having single tone. That is the reason you will get one impulses. Okay, you will get impulses. Similarly, if you are drawing on negative frequency side, okay, at minus FM1, at minus FM2, you will get the signal strength. Okay, so that means whatever the frequencies that you are getting, it is centered around origin or centered around zero. That is the reason this particular signal we will call it as baseband signal. But now if you observe these frequencies, like here it is centered around where? FC. It is centered around FC. FC plus 10K, FC minus 10K. Similarly, here FC plus 15K, FC minus 15K. So that means all the four frequencies that you are going to get here, okay, those are centered around FC, right? So here FC is the very high frequency signal. So that is the reason here this particular signal we will call it as, like, instead of base band, we will call it as band pass signal. Band pass signal. Whenever any signals, okay, what are the spectral components that you are having, if those spectral components are centered around some very high frequency, then that particular signal we will call it as band pass signal. Okay, right. Now just observe these 4 frequencies. Just observe these 4 frequencies. Among all the 4 frequencies, which one is the larger one and which one is the smaller one? Among all the 4 frequencies, which one is the larger and which one is having smallest value? Yes, just observe here. First of all, if you want to know among all the 4 frequencies which one is the maximum, okay, so just you have to observe regarding the addition, right? Here from FC, it is just you are adding 10K, but here for FC you are adding 15K. So when compared to 10K, 15K is larger, right? So here you are subtracting, okay, so that means among these two, when you have observed, this is nothing but your F max, maximum frequency. Among all the frequencies, you got the maximum frequency. Similarly, regarding the minimum one, among all the 4 frequencies, if you are supposed to find the minimum, okay, you have to just observe the difference, that's all. Just observe this one and this one. Here from FC, you are just subtracting 10K only, but here you are subtracting 15K. So that means among these two, this one is the smaller one, right? So that means overall you are getting, this is the minimum. Among all the 4 frequencies, we have identified the maximum frequency is this one and minimum frequency is this one, right? Now the question is regarding the given signal, okay, for this particular signal we have to calculate the bandwidth, okay. So for the given signal, total you are getting 4 frequencies, among which this is the maximum frequency and this is the minimum frequency, right? Now regarding bandwidth, bandwidth is nothing but among all the frequencies, whichever is the maximum that you have to consider, minus whichever is the minimum that you have to subtract, okay. Range of frequencies where you are operating the signal, that is nothing but what? Bandwidth, okay. So here F max is FC plus 15K, FC plus 15 kHz, and F min is FC minus 15 kHz, FC minus 15 kHz, right? Here plus FC minus FC will get cancelled, minus of minus plus, right? So 15K plus 15K, so that together you will get 30 kHz. Okay. So for understanding purpose, okay, we have solved case by case and from there we have given the generalized, okay, for understanding purpose. But for the same question, okay, if you want to answer directly regarding the bandwidth, it is very simple. You can observe from the previous question. Here we are having, regarding the modulating signal, we are having only one frequency, right? So obviously when you look at these 2 frequencies, this is the maximum one, this is the minimum one, this is the maximum and this is the minimum, right? So regarding bandwidth, here maximum frequency is FC plus FM minus minimum frequency is FC minus FM. So here plus FC minus FC will get cancelled, minus of minus is plus, so FM plus FM, together you are getting 2FM. So that means if you are having, regarding the modulating signal, if you are having only one frequency, right, that particular frequency you have to multiply with 2, that's all, that is the bandwidth. But whenever you are having the modulating signal, if it is having multiple frequencies regarding the modulating signal, in this particular example we are having FM1 10 kHz and FM2 15 kHz, like that. Even suppose if you are having 3 signals or 4 signals, 5 signals, whatever the number of signals, okay, you are having, regarding the modulating signal, if you are having multiple frequencies, right, among all the frequencies, whichever is the largest one, that particular frequency you have to consider, just you have to multiply with 2, that's all. Yes or no? You can observe here among 10K and 15K, 15K is the maximum, okay. So just multiply 15K with 2, that is nothing but 30 kHz. How much time it is required? It won't take much time, yes or no? In this way, you can easily solve regarding DSBSC questions. Most of the questions you can easily solve without using pen and paper. Only for understanding the concept point of view, I am just discussing elaborately, okay, based on the possibility, how much it is required, I am explaining. But once if you understand the mechanism, once if you understand the concept clearly, then you can easily solve these kind of questions without using pen and paper. That's all. Okay, I hope all of you got the clarity, whatever the conclusion point from this particular question. Whenever you are having multiple frequencies regarding bandwidth, okay, 2 times FM here, or if you want you can mention like F max, 2 times F max. Whenever you are having multiple frequencies regarding the modulating signal, among all the frequencies, whichever is the maximum, that one you can consider and multiply with 2. That's all. That is nothing but bandwidth. This is for generalized case. So all of you try the next question. This is the MCQ. Obviously, one option will be correct. This is very interesting question. All of you give it a try. Yeah, here you are having m of t, that is the message signal. Here it is mentioned single tone. Single tone means it is having single frequency. Okay. Here it is mentioned 5 kHz. Regarding the modulating signal, we are having the corresponding frequency as 5 kHz. And in this particular diagram, you are having delta omega. Regarding that, they have given the value. Delta omega is 2 pi into 0.5 k radian per second. Now the question is, here you are having low pass filter. Here you are having low pass filter. Regarding that particular low pass filter, what cutoff frequency we have to choose in the order of kilohertz so that we can extract or we can recover the modulating signal at the output. Okay. So here omega is nothing but carrier frequency. See, regarding modulating signal frequency or message signal frequency, they have mentioned 5 kHz. Regarding carrier signal, in general we will represent as f suffix c. Okay, but in this particular example, they have considered like omega, where omega is nothing but 2 pi f. So that means here f is nothing but carrier frequency. Okay. So here if you observe this particular block diagram, here you are having one multiplication symbol, right? So this indicates what? Multiplier, or we can say it is the DSB-SC signal. Okay, the DSB-SC modulator or product modulator. Here we are having message signal and here we are having carrier signal. Those two signals we are just multiplying so that we are getting the DSB-SC. Here we will get DSB-SC. Okay, and that signal we are passing through the channel. After that once again we are using the multiplier here, and now in this case, in this multiplier, one of the signal is DSB-SC and other one is once again one more carrier signal. Okay, one more carrier signal, but here whatever the operating frequency you are having, omega, here you are getting like omega plus delta omega. Instead of omega, you are having omega plus delta omega. Okay, now after that, what is the signal that you are getting? That signal we are passing through low pass filter. Okay, as the name implies, low pass filter allows only low frequency, right? It will reject all the higher frequencies, right? Now regarding this low pass filter, what cutoff frequency maximum we have to consider so that we can extract the message signal, right? Message signal is having the frequency 5 kHz. In order to extract this particular frequency, what cutoff frequency we have to choose for low pass filter? That is the question, right? I hope all of you got the clarity here regarding the question, what data they have given, what we are supposed to do, right? I hope it is clear for everyone, right? So here regarding message signal, we are having the frequency 5 kHz. So this is nothing but what? F suffix m. Message signal frequency we are having f suffix m. And here cos omega t. So regarding this we already mentioned omega is nothing but 2 pi f. So that means carrier frequency we are having f. Okay, in general we will be having fc, but here in this particular example, in this particular question, it is f. So for the time being I am representing output of first multiplier. Output of first multiplier as s1 of t. Output of second multiplier as s2 of t for easy understanding. Okay. So regarding s1 of t, we no need to write any mathematical equations. Whatever observation, even in this particular session, the first question we have discussed, where you are having one block diagram, there simply you are having multiplier and you are having two inputs. We have multiplied both the signals, right? So that is nothing but output you are getting, that is nothing but DSB-SC only, correct? Right. So whenever you are getting DSB-SC or whenever you are multiplying two signals, right, either two sine signals or two cos signals, or one is sine, one is cos, whatever it may be, right, you will get at the output two frequencies. One is addition of those two frequency and other one is difference of those two frequencies. That's all, right? So here regarding s1 of t, okay, here you are having multiplier. For that multiplier you are having two signals. One is modulating signal, the corresponding frequency is fm, and similarly regarding the carrier you are having the frequency f, right? So here you will get fc plus fm, but here fc is nothing but f, okay, f plus fm, and another frequency you will get f minus fm. Okay, in this particular example, fm already they have given 5 kHz. So f plus 5 kHz, and other one is f minus 5 kHz. I hope it is clear up to this point. Now, this particular signal we have passed through the channel, so that means same frequencies you will be having. Okay, no problem. Now at the second multiplier, we are getting one signal which is nothing but the product of these two signals. One signal is S1 of t, another signal is cos of omega plus delta omega t. Okay, for reference I will mention here S2 of t is nothing but S1 of t into cos omega plus delta omega t. Okay, so here S1 of t into cos omega we can write as 2 pi f plus delta omega. In the question it is mentioned 2 pi into, regarding delta omega it is mentioned 2 pi into 0.5 k, 2 pi into 0.5 k. Omega is 2 pi f and delta omega is 2 pi into 0.5 k into t. Okay, right. From here you can take 2 pi as common. S1 of t into cos, you can take 2 pi as common, then you will get f plus 0.5 k, f plus 0.5 k. Here k is nothing but kilo, Now just observe. In the originally regarding DSBSC signal, what we have mentioned, one is message signal, another one is carry signal, right? Similarly here, one signal is S1 of t, another signal you are getting like cos 2 pi. Here in place of f, you are having f plus 0.5 k. So now in this particular example, this is nothing but your carrier frequency, right? So regarding S1 of t, now if you observe, you are having two frequencies. Okay, for the time being, if you want, you can label this one as f suffix 1 and this one you can consider like f suffix 2. Now if you observe this part of the diagram, if you observe, it is like whatever the signal S1 of t you are having, that you are in that particular signal you are having two frequencies, right? Okay, now f1 is one frequency, f2 is another frequency, both are related to S1 of t. Now regarding the carrier, we are having the frequency f plus 0.5 k. Now we are performing multiplication only. Okay, whenever you are performing multiplication of two signals in time domain, okay, that time that you will get two possible frequencies. Okay, so one is addition of two frequency, another one is subtraction of those two frequency. But here in this particular example, regarding S1 of t itself, you are having two frequency. That means now can you guess how many total frequencies you will get at the output of second multiplier? How many frequencies that we are going to get? Yes, we will get 4 frequencies. Very good. We will get 4 frequencies. See here, first let us consider with respect to f1. Okay, so we have to perform addition. So here frequency is f plus 0.5 k, plus here f1 is nothing but f plus 5k. I hope it is clear. Whatever the frequency here you are having, this frequency we have to add to f1, where f1 is nothing but f plus 5k. So from here you will get f plus f is 2f, 5 plus 0.5, that is 5.5 k. Right, this is one frequency you are going to get, one frequency. Now another one is what? Difference of frequency. Now just observe this frequency and this frequency, which one is larger? Yeah, here f plus 0.5, here f plus 5, obviously this is larger, right? So you can subtract smaller from larger, so you will get f plus 5k minus of this entire frequency, f plus 0.5k, f plus 0.5k. That's why I have told earlier, whenever you are subtracting two frequency, just observe among those two frequency which one is the smaller. Okay, you always subtract smaller from larger, because practically we never have negative frequency. That is the reason, right? Suppose if you don't know initially which one is the larger, which one is the smaller, okay, that time you can just perform the subtraction, but okay, but luckily if you are subtracting smaller from larger, definitely that itself is the final answer. But suppose if you are subtracting larger from smaller, that time you will get negative, right? Just take the modulus, that's all. So here plus f and minus f will get cancelled. 5 minus 0.5 is nothing but 4.5 kilohertz. Okay, so this is the second frequency. See, when you are having only this frequency, okay, and here regarding the carrier frequency you are having f plus 0.5k, you are getting addition of two frequencies and you are getting subtraction of two frequency. But in this particular example, regarding S1 of t, we are having two frequency. With respect to f1, we have written like this, right? Now with respect to f2, similarly you have to follow. So once again, addition. Whenever you are performing addition, you don't need to check which one is the smaller, which one is the larger. No problem at all, right? Just simply you are performing addition, right? So here f plus 0.5k, f plus 0.5k. Next, here frequency is f minus 5k. F minus 5k. F plus 0.5k plus f minus 5k. So here f plus f, 2f, and minus 5 plus 0.5 is nothing but minus 4.5 kilohertz. So this is the third frequency. And the last frequency, last one or fourth one, you have to separate these two frequencies. Now tell me which one is the larger? Which one is the larger? Here f plus 0.5, here f minus 5. Obviously, here when you look at, you are subtracting, right? So this will be smaller. Here you are performing addition. Obviously, this is greater when compared to this one, right? So now you can separate this frequency from here. So this is the fourth frequency. So at the output of first multiplier, we are getting two frequencies, and at the output of second multiplier, we are getting four frequencies. Now this S2 of t, even though you are having four frequencies, but since we are passing through the low pass filter, as the name implies, low pass filter will pass only the low frequency signals, right? Low pass filter will pass only the low frequency signals. Suppose if they have mentioned high pass filter, it will pass only high frequency signals, right? What is the cutoff frequency you are considering? From that cutoff frequency, all the higher order frequencies will be passed. If it is a low pass filter, means up to the cutoff frequency, starting from 0 up to the cutoff frequency, it will pass only those frequencies, right? Similarly, band pass filter means it will pass some band of frequencies. It is having lower cutoff frequency and higher cutoff frequency. Only some band of frequencies it will pass. Whereas band reject filter, if you are having, it will just reject that band of frequency, but it will pass the remaining band and it will pass another band. Okay, right? In this way, you will be having, regarding the filters, you will be having four possible filters. Of course, all pass filter you might be having fifth filter, but as the name implies, all pass filter means it will pass all the frequencies, right? Okay. Now you are having, regarding the second multiplier output, you are having four frequencies. Now we are passing these four frequencies through this low pass filter. Okay. Now if you are passing through low pass filter, finally what are the output frequencies that you are going to get? Out of four frequencies, which frequencies you will get at the output of low pass filter? All of you just observe and tell me. Yes, just observe here. Here you are having 2f plus. Okay, here f is what? Carrier frequency. In general, you will be having in the order of megahertz, right? Or maybe in the order of kilohertz, multiples of 100. So that means it is very high frequency. So this particular frequency won't pass this low pass filter. Similarly, here also you can observe 2f is very high frequency. From there you are subtracting 4.5k. So this particular frequency also very high. Okay, so these two frequencies it won't pass. Now you can observe here you are having 4.5 kHz, here you are having 5.5 kHz. Okay, 4.5 kHz, 5.5 kHz. Okay, so low pass filter will pass these two frequencies. You are having in the order of kilohertz, Okay, right. 4.5k and 5.5k you are getting. At the output of low pass filter, you are getting two frequencies. One is 4.5 kilohertz, another one you are getting 5.5 kilohertz. Okay, now just look at the question and choose the correct answer. In order to recover the message signal, what should be the cutoff frequency of the low pass filter? They haven't asked regarding the output of low pass filter what frequencies we are getting. That is not the question. Here the question is, in order to get the message signal at the output, what cutoff frequency we have to choose for the low pass filter? This is a very interesting question. All of you please mention your answer in the chart. See the beauty of this question. Here you are getting at the output of low pass filter, you are getting two frequencies. One is 4.5 kHz, another one is 5.5 kHz. Okay, so since you are getting 4.5 and 5.5, okay, so some of you might have chosen like option C or option B. Okay, but see the beauty of this question. Here regarding the message signal, the corresponding frequency that you are having is 5 kHz. So here underline this word, to recover modulating signal. If you want to recover the modulating signal, that particular signal should have the frequency 5 kHz. But surprisingly, we haven't get 5 kHz frequency here. Suppose if you could have got 5 kHz, okay, then accordingly you could have chosen among the given options. Okay, but here 5 kHz is not there. 5 kHz is not at all present. That means whatever may be the low pass filter cutoff frequency you may choose, you never get the message signal at the output, because you just observe these frequencies. Here you are having 4.5k, 5.5k. Neither of the two frequencies belong to this frequency, right? So that is the reason option D is the correct answer for this question. This is a very interesting one. M of t cannot be recovered. Whatever may be the cutoff frequency you may choose for low pass filter for this particular example. Okay, all of you can put the star mark for this question. This is a very, very interesting question. Next question, which is asked in GATE EC 2020 for 2 marks. All of you give it a try. Yeah, in this question, you are having the block diagram. Okay, in this block diagram, if you observe, you are having the multiplier. For that multiplier, you are having two signals. Here x of t is one of the input, another input is the carrier signal. Here, regarding carrier signal, you are having the frequency as fc plus 40. Okay, fc plus 40 is the carrier frequency. Okay, right. In general, if you are having simply fc, 2 pi fct format, so the regarding the carrier signal frequency is fc. But here, instead of fc, you are having fc plus 40. Now see the beauty of this question. For this multiplier, you are having x of t, but here x of t is nothing but what? X of t is nothing but m of t multiplied with cos 2 pi fct. So that means what is x of t here? X of t is DSB-SC signal. Okay. So here you are given the DSB-SC signal. Okay. DSB-SC signal and then one more carrier signal. Okay. Just you are multiplying that output, you are passing through low pass filter. In this particular example, regarding the low pass filter, they have given the cutoff frequency 510 Hz. Okay, 510 Hz they have given cutoff frequency. Here, suppose if you are considering like this, so here you will be having center frequency 0. In general, we will represent positive side. Just for symmetrical, you can represent negative frequency. Okay, right. Now the question is regarding the output of the low pass filter. Okay, whatever the signal that you are going to get, that you have to choose among the given 4 choices, whichever is the correct one. Okay, right. I hope all of you got the clarity regarding the question. What are the sentences they have given, what information they have given, what is the block diagram they have given, what we are supposed to calculate. Okay, right. Now follow the same approach. First of all, regarding x of t, you are having message signal multiplied with carrier signal, right. So here regarding the message signal, they have mentioned 4 cos 1000 pi t, So this one you can write 4 cos, this one you can write in the form of 2 pi f. Okay, so here 1000 pi you are having, that one I am writing it as 2 pi into 500 t, 2 pi into 500 t. Now you are getting the standard form cos 2 pi fmt, right. So that means here 500 is nothing but fm, that means modulating signal frequency. And regarding carrier frequency, they have mentioned 1 megahertz. Okay, that value we can substitute later. Okay, right. Now regarding x of t, we are having 2 signals we are multiplying. One is message signal, another one is carrier signal. We are multiplying in the time domain. Then you will get 2 frequencies. What are those 2 frequencies? So I am writing regarding the x of t. We are getting 2 frequencies. One is addition of those 2 frequencies, that means fc plus fm. Another one is difference of those 2 frequencies, fc minus fm. Double sideband suppressed carrier, right. Here fc value we no need to substitute. Okay, later if required we can substitute, but here for the timing it is not required, but fm value can substitute. Fm is 500. Here fc minus fm is 500. Okay, why I am not substituting regarding fc, you will come to know shortly. Okay, right. I hope it is clear up to this point. Now in this particular diagram, you are having the multiplier. So this multiplier output for the timing I am assuming as s of t. Okay, multiplier output I am assuming s of t. So here s of t is nothing but x of t and this carrier signal we have to multiply, right. So here regarding x of t, we are having 2 frequencies. You are going to get how many possible frequencies we may get? Yes, same, 4 possible frequencies we will get, just like the previous question. See, if you are having only 1 frequency here, okay, and here you are having carrier, so you will get addition of frequency and you will get subtraction, that means only 2 frequency. But like that you are having 1 more frequency, so because of this one you are getting 2 frequency, because of this one also you will get 2, so together you will get 4 frequencies, right. Now regarding S of t, just one second. So regarding S of t, first of all let us consider the addition of 2 frequencies. Okay, here the carrier frequency is Fc plus 40, just like here Fc plus Fm, right, but here in place of Fc you are having Fc plus 40, plus here regarding X of t, let us consider this frequency first, that is Fc plus 500, Fc plus 500. So from here we are going to get Fc plus Fc is 2Fc, Fc plus Fc is 2Fc, then 40 plus 500, that is 540 Hz. So this is one frequency you are getting, this is the first frequency. Now the second one is what? Difference of those 2 frequencies, right. So when you look at Fc plus 40, Fc plus 500, which one is the larger? Obviously this one is larger, so you can subtract smaller from larger, right. So Fc plus 500 minus Fc plus 40, So here Fc will get cancelled, 500 minus 40, which is nothing but 460 Hz. Okay, 460 Hz. plus 40 is 500, right? That is the second frequency. Now, with respect to this frequency, we have performed the addition, we have performed the subtraction, right? Similarly, with respect to this frequency, now let us perform addition of these 2 frequency and let us do the subtraction. Okay, so first of all, let us perform addition. So next one, Fc plus 40 plus Fc minus 500. So here Fc plus Fc, that is 2Fc, plus 40 minus 500. So that means you are getting minus 460. So this is the third frequency you are getting. And the last one is we have to subtract. Now just tell me, among these 2 frequencies, which one is the smaller? Obviously this is the smaller because you are subtracting, right? Here you are performing addition, so obviously this is the larger when compared to this one, right? So the fourth frequency, so you can consider higher one, Fc plus 40 minus Fc minus 500. So here Fc will get cancelled, minus of minus plus, so that means you are getting 540 Hz. So this is the fourth frequency. So in this given block diagram, at the output of this multiplier, we are getting a signal which is having 4 frequencies. We are getting a signal S of t which is having 4 frequencies. 2Fc plus 540, that is one frequency. 2Fc minus 460, that is another frequency. 460, that is one frequency, and 540 is another frequency. Okay, this particular S of t is having 4 frequencies. Now we are passing this particular signal through low pass filter. And which is having the cutoff frequency 510 Hz, So that means here this particular low pass filter will pass the frequencies from 0 to 510 Hz only. It will pass only the low pass frequencies. Okay, The highest frequency that it can pass is 510 Hz and the lowest frequency is 0. Okay, so within this range, whatever the frequencies that you are having, only those frequencies it will pass, and the remaining frequencies it will reject. Okay, now with this understanding, can you observe among all the 4 frequencies, which frequency the low pass filter is allowing? See here, 2fc plus 540, this is the highest frequency, right? So it won't pass. And here 2fc minus 460, this is also high frequency, it won't pass. Now 460 Hz, 540 Hz, these are the somewhat low frequencies, right? Now since in this question you are having cutoff frequency what? 510 Hz, upper cutoff you are having 510 Hz. So that means 540 Hz, whether it will pass? No, because 540 is what? Greater than 510, right? It won't allow any high frequency. Okay, the frequencies which are just beyond 510 Hz, all the frequencies are rejected, right? So since 460 Hz will fall within this range, right? So obviously this frequency it is allowing. Out of 4 frequencies, only one frequency component the low pass filter is allowing for this question, right? I hope all of you got the clarity. Say for example here, instead of 540, suppose you got 500 Hz, okay, and if the question is MSQ, right, then 460 Hz it will pass, and similarly 500 Hz also it will pass. But the question is MCQ, obviously one option will be correct, right? So here 460 Hz signal it is passing. That means at the output of low pass filter, you are going to get a signal which is having the frequency 460 Hz. Now you are getting 460 Hz. Okay, the moment you got 460 Hz, okay, some of you in the GATE exam, okay, in hurry, okay, some of you directly choose this option, whether it is correct, whether option D is correct. Is it correct or not? It is not correct. Why? Because here you are having the format like what? Cos 2 pi ft format. But here directly that value you are getting 460 pi t. But now what you have to consider? You are getting 460 Hz. Okay, so that one we have to write here 460 Hz you are getting, right? Okay, so now you have to write in the standard form, cos 2 pi f format, cos 2 pi into 460, cos 2 pi ft. So here 2 into 460, so that means you will get 920 pi t. So you have to be very smart, okay, even though after solving the question something you are getting, okay, but according to the context you have to answer carefully, right? So here frequency wise it is correct only, but when you are representing the standard form you will get cos 2 pi ft, right? So you have to multiply with 2 pi, from there you are going to get 920 pi t. Okay, now you can choose the correct option. Yes, option B is the correct one. I hope it is clear for everyone. Next question, which is asked in GATE EC 2014 set 2 for 2 marks. This is a very interesting question. All of you read the question and try to solve, and what is the option you are going to get, you can mention in the chart. Yeah, this is a very interesting question which is asked in GATE EC 2014 for 2 marks. So here, regarding the message signal, they have given the corresponding frequency spectrum. Okay, here you are having m of f, that is nothing but the Fourier transform of the message signal m of t. Okay, you are having time domain signal m of t. For that, if you apply Fourier transform, you will get the corresponding spectrum. Okay, so here you are having the corresponding frequency spectrum m of f. Okay, so from here, if you observe, you are having x-axis is the frequency. Okay, so this is the center frequency 0, and this is the positive frequencies. From B to A, the signal is having, and similarly, for theoretical purpose, you can represent on negative frequency, but in general, you will be having only positive frequency, right? Okay, fine. Now, regarding A, they have mentioned 100 Hz, and regarding B, they have mentioned 40 Hz. So that means regarding the modulating signal or message signal, previously if you observe, you are having, in some questions you are having only one frequency, and some questions you are having like 2 frequencies. Okay, but in this question, you are having the range of frequency. Right? So regarding the modulating signal, now we are operating from 40 Hz to 100 Hz. Yes or no? Here B is the 40 Hz and A is the 100 Hz. So from 40 Hz to 100 Hz, all the frequencies we are allowing. Right? So in this particular question regarding the modulating signal, we are operating the range of frequencies. Instead of only at finite frequencies, we are operating some band of frequencies. Okay, right, fine. Now, so that m of t we have given here. Okay, m of t we have given here, and regarding v of t, you are having the carrier signal cos 2 pi f ct. So this is a multiplier. So output you will get DSB-SC. Now that DSB-SC we have passed through the high pass filter. Okay, high pass filter means it will pass only high frequencies. Now once again we are using multiplier. Now for this multiplier, one of the input is whatever the output you got here, that output after passing through high pass filter, that output we are giving as input. Okay, that is the beauty. In one of the earlier question, we have considered the channel. Whenever channel means whatever the signal you are getting, the entire signal we are transmitting. But here we are using filter. Whenever, as the name implies, filter means we are filtering, right? We are not allowing all. Yes or no? Here it is mentioned high pass. So that means it is passing only high frequency components. Okay. Now regarding W of t, it is mentioned here, this is carrier signal only, but here the corresponding frequency you are having Fc plus C. Now this output, now we are passing through low pass filter. So this low pass filter output S of t you are having. Regarding that particular signal, what is the bandwidth? That is the question. What is the bandwidth? Okay, in the previous question, similar to this one we are having, but there output of the low pass filter, okay, there we have calculated the corresponding frequency, okay, corresponding equation, time domain equation, but in this question they are asking the calculate bandwidth of the output signal. Okay. So it is very simple. Whatever the procedure earlier we have discussed, follow the same procedure. Step by step, if you do systematically, you can answer these questions easily, right? So first of all, just observe regarding m of t, we are having range of frequencies. Here lower frequency is 40 and higher frequency is 100. So regarding m of t, we are having the frequencies that we are operating from 40 Hz to 100 Hz. Okay. Next, regarding the carrier signal, we are having the frequency Fc. Regarding the carrier signal V of t. Regarding V of t, we are having the carrier frequency as Fc. Now the multiplier will produce 2 frequencies, as you all know. Those are nothing but Fc plus Fm, another one is Fc minus Fm. Output of first multiplier. output of first multiplier. We will get Fc plus Fm and Fc minus Fm. Here Fc is the single frequency only, but Fm is the range of frequency, right? So accordingly you will get Fc plus starting frequency, you will get Fc plus 40 to highest frequency you will get Fc plus 100. Fc plus 100. Similarly, here you have to subtract Fm from Fc, right? So now when you are subtracting, okay, so here you will get Fc minus 40 and Fc minus 100. Okay, so when you are mentioning the range, among Fc minus 40 and Fc minus 100, which one is the smallest one? Fc minus 100, yes or no? From Fc you are subtracting the larger one, so that means obvious that value will become smaller. Okay, when you are subtracting smaller, that means that value will become bigger, right, when compared to the other. So that means here in this case, okay, you can write Fc minus 100 to Fc minus 40. I hope it is clear. When you are performing the addition, you are getting the range. Range always you will represent from minimum to maximum, right? So Fc plus 40 to Fc plus 100. Suppose for easy understanding, consider Fc as 200, example. 200 minus 100 is 100. 200 minus 40, 160. 200 minus 100 is 100. 200 minus 40 is 160, right? So that means 100 to 160, right? Range always will represent from minimum to maximum, yes or no? If you want, you can consider ulta, but generally we will represent minimum to maximum, right? Range of values. Okay, that is the reason I have represented like this. Fine. So output of first multiplier, we are getting range of frequencies like this. Fc plus 40 to Fc plus 100. Another range, you are getting Fc minus 100 to Fc minus 40. Okay. Now this multiplier output, okay, we are passing through high pass filter. And it is having the cutoff frequency Fc. Here we are using two filters. For both the filters, cutoff frequency is same, Fc. Okay. So as the name implies, high pass filter will allow only high frequencies, and starting from where? Starting from the cutoff frequency. Now just observe. Among here we are getting two range of frequencies. Okay. So which range of frequencies this high pass filter allow? First one or second one? This is the first one and this is the second one. So which one it will pass? See, regarding high pass filter, you will be having like this. Starting from cutoff frequency, all the high frequencies it will pass. That means whichever frequencies are greater than Fc, all the frequencies it is passing. Whichever frequencies are smaller than Fc or lower than Fc, those frequencies it is not passing. Now you can easily observe. When compared to Fc, Fc plus 40 is greater or not? Yes. Similarly, Fc plus 100, it is greater. Okay. What about this one? Fc minus 100, Fc minus 40, those are lower than Fc, right? So this range of frequencies it is not passing. Only this range of frequency it is passing. Okay. So at the output of high pass filter, we are getting the range of frequencies. Only this one, Fc plus 40 to Fc plus 100. Fc plus 40 to Fc plus 100, right? Now this is one of the signal for this second multiplier, and other signal is W of t. Okay. So just for understanding, I will write here. For second multiplier, we are having, okay, I will write like this. Output of second multiplier. Which is nothing but output of high pass filter, and another one is W of t. Okay. So regarding output of high pass filter, we got the frequency ranges fc plus 40 to fc plus 100, right? So you can mention the corresponding frequency range fc plus 40 to fc plus 100. The range of frequencies that we got at the output of high pass filter is fc plus 40 to fc plus 100, right? Now regarding w of t, you can observe the frequency fc plus a, fc plus a. Regarding w of t, the frequency we are operating is fc plus a, where a is nothing but 100. A is nothing but 100. Now here we are having the multiplier. We know very well, okay, whatever the two time domain signals that we have given as the inputs for multiplier, it will produce at the output two possible frequencies, right? So here whatever the frequencies here we are having regarding this signal and this signal, we have to perform addition, and similarly we have to perform subtraction, right? So just like the earlier one, you will get two range of frequencies, right? So first of all, you can perform addition. So at output of second multiplier, we are going to get, just perform the addition. So here fc plus 40, fc plus 40 plus fc plus 100. That is the starting frequency, and ending frequency will be, just add these two, fc plus 100 plus fc plus 100. So from here you will get 2 times fc plus fc is 2fc, and 40 plus 100 is 140. This is the starting frequency, and here also fc plus fc is 2fc, and 100 plus 100 is 200. So this is one range of frequencies that we are going to get, one range of frequency. Okay. Another range of frequency is what? Just we have to perform difference. Okay, just like earlier when you are performing difference. Okay, so here range always will represent minimum to maximum, right? So say for example, when you are subtracting from this one, when you are subtracting fc plus 40, you will get like 100 minus 40 is 60, whereas here 100 minus 100 is 0. So that means if you subtract these two, that is the minimum, frequency, and when you are subtracting these two, you are getting somewhat higher, right? So another possibility regarding the frequency range that you are going to get at the output of second multiplier is, so starting one, I am considering this one and I am subtracting this one, fc plus 100 minus fc plus 100. So this is starting frequency, and ending frequency among these two, this is the larger, right? So fc plus 100 minus fc plus 40. So here plus fc minus fc will get cancelled. 100 minus 100, that is nothing but 0. Next 100 minus 40 is 60. So we are getting two range of frequencies. One range of frequencies you are getting like 2fc plus 140, it is a starting frequency, ending frequency is 2fc plus 200, right? Another range of frequency you are getting 0 to 60 Hz, 0 to 60 Hz. Now what is the question? Just observe. Up to now you got output of second multiplier. Now the second multiplier output we are passing through low pass filter. Which is having the same cutoff frequency fc, Now just observe, you are having two range of frequencies. So which one it will pass? Obviously it will pass only this one, because here you are having high frequencies, yes or no? It is starting from 2fc, so that means it is very high frequency when compared to fc, because for low pass filter cutoff frequency is fc. From fc when you compare, this range of frequency is very high, okay? But here if you observe 0 to fc, so within that range you are having 0 to 60. Yes, it will pass, okay? So at output of low pass filter, we will get the range of frequencies 0 to 60 Hz. 0 to 60 Hz. So here the minimum frequency is 0 and maximum frequency is 60 Hz, right? Here the question is, we have to calculate the bandwidth of that particular signal, that's all. So bandwidth is nothing but highest frequency minus lowest. So here 60 minus 0, that is nothing but 60 Hz. So the final answer for this question is 60. I hope it is clear for everyone. See, here for understanding purpose, we have completely solved this question, but actually for solving this question without using pen and paper also you can solve, okay, and even in less time you can solve. Just observe here, whatever we have discussed from the beginning of this particular session, whatever the conclusion points are there regarding the multiplier, if you simply apply, and wherever filters are there, if you carefully observe according to the given filter, okay, so you can do all the calculation that we have discussed. In fact, entire calculation not at all required for solving this question, but for understanding purpose, I have discussed at each and every stage what are the possible frequencies that you are going to get. But for answering this question, if you observe the given diagram and if you have observed the block diagram carefully, you no need to use pen and paper. Without using pen and paper, you can solve this question and you can get 2 marks in less time. How it is, let us see. See, this is the original signal you are having. This is a original signal, that is a modulating signal. Okay, here you are having the starting frequency 40 Hz and the maximum frequency you are having 100 Hz, right? So that means regarding this particular signal, you are having 40 Hz to 100 Hz, 40 Hz to 100 Hz, or in simple words, regarding the bandwidth of modulating signal, what is the bandwidth you are going to get? Bandwidth of modulating signal, bandwidth of m of t, how much? A minus b, a minus b. Here a is nothing but 100 minus b is nothing but 40, so you are getting 60 Hz. 60 Hz, right? Yes. Now you are having the bandwidth of the original modulating signal as 60 Hz, right? Okay. Now what you are performing here? You are performing multiplication operation. That means at the output you are going to get DSBSC. There you will get 2 frequencies. One is addition of these 2 frequencies, another one is subtraction. Here the filter name is high pass filter. That means it will pass only high frequency. Like say for example, regarding V of t, the carrier signal frequency is Fc, right? So Fc plus Fm and Fc minus Fm. So when compared to cutoff frequency Fc, it will pass only Fc plus Fm, right? It will pass only Fc plus Fm. So that means it won't pass Fc minus Fm. Okay, right. So here you are getting, so for easy understanding, here I am just telling that here you will get Fc plus Fm and Fc minus Fm. But here high pass filter, you are going to get only Fc plus Fm. Fc plus Fm. Now regarding W of t, you are having Fc plus A. Here W of t, Fc plus A, where A is nothing but 100. Where A is nothing but 100. Now once again you are using multiplier. You will get addition of these 2 frequency and subtraction of these 2 frequency, right? So here you will get addition and you will get subtraction. But now see the beauty here. You are using low pass filter. Whenever you are using low pass filter, it won't allow high frequency signal. That means it will pass only low frequency signals and up to the cutoff frequency Fc. So that means instead of performing addition, even if you perform addition, what you are going to get? Okay, just for understanding purpose I will write, no problem. Just perform the addition. Fc plus Fc is what? 2Fc plus Fm plus 100. Okay, 2Fc plus Fm plus 100. And if you subtract these 2 frequency, Fc will get cancelled. 100 minus Fm. 100 minus Fm. Okay, 100 minus Fm you will get, right? So now among these 2 frequency, when you compare with respect to FC, 2FC is what? Greater, right? So it won't pass, it will pass only 100 minus FM. It will pass only 100 minus FM. 100 minus FM. So regarding the modulating signal, whatever the bandwidth, so that means now if you observe carefully, here in this particular example, we calculate the bandwidth, but actually for Vernier signal, modulating signal, you are having actually, instead of single frequency, you are having what? Range of frequency. You are having range of frequency. Here it is starting from 40 and ending at 60. Hertz. Right? Sorry, here when you are subtracting, FC will get cancelled and just one second. Here 40 Hz to 100 Hz. Yes. So here you are getting 100 minus FM. Okay. Here you are getting 100 minus FM. Right. So just observe here. Here originally you are having regarding FM 40 Hz to 100 Hz. 40 Hz to 100 Hz. Right. So here 100 minus FM. 100 minus FM. So that means 100 minus 40. 100 minus 40 is 60. And 100 minus 100 is 0. So that means 0 to 60 Hz. 0 to 60 Hz. I hope it is clear. See, here you are getting 100 minus FM. So 100 minus 40 is 60. 100 minus 100 is 0. Among this, the minimum value is what? 0 and maximum value is 60. So finally you are getting 0 to 60 Hz. So the bandwidth is nothing but 60 Hz. Okay. In simple words, here for understanding purpose, I have represented the representation, but once if you understand this overall block diagram mechanism, whatever the bandwidth you are having for the original modulating signal, the same answer you are going to get at final. That's all. The same answer you are going to get. For the given signal, the bandwidth is 60 Hz. Obviously, the final answer for this question is 60 Hz. The final answer for this question is same, 60 Hz. Okay, here I have explained everything clearly step by step, and same thing, instead of representing the values, okay, I have explained here also once again, but without using any notation, just by observing the phenomena, what are the possible frequencies you are going to get and what kind of frequency it is passing. Okay, ultimately if you observe clearly, it is passing with the help of high pass filter, it is passing some band of frequency, and similarly with the help of low pass filter, we are passing some band of frequency, right? And here if you observe the overall phenomena, it is passing this kind of frequencies, right? The range of frequencies it is passing, but the band of frequency here in the original signal you are having like 40 to 100. In this particular here you are going to get like 0 to 60, that's all. But this entire band it is passing. Whenever it is passing the entire band, so obviously the bandwidth will remain same. This is the conclusion point that I want to mention here. For solving this question, once if you understand the overall block diagram, okay, the phenomena, you no need to use pen and paper. Without using pen and paper, whatever the original modulating signal bandwidth you are having, the same bandwidth that you are going to get at the final. That's all. That's all. Okay. So in this particular session, we have discussed variety of questions, very interesting questions which are related to DSBSC. Okay. So initially we have discussed with the help of mathematical approach, and once if you have understood regarding that particular mathematical approach, what are the final frequencies that you are going to get? What are the final frequencies that you are going to get whenever you are using multiplier or product modulator or balanced modulator, right? So whatever the two signals that you have given, regarding those two signals, okay, each one will be having the frequencies, right? You have to add them, you have to separate them. Those two frequencies that you will get at the output of multiplier. After that, whichever filter they are using, accordingly the respective band of frequencies it will pass. Okay. So we have discussed variety of questions and interesting questions which are very much helpful for all of you. Okay. Tomorrow we are having one more session. So in that session we will continue further some more questions regarding DSBSC, and then we'll discuss the questions regarding SSBSC. So all of you kindly share this video link with all of your friends, and even if you have missed earlier sessions, so kindly watch those sessions also. The playlist is available in our channel. Okay. So kindly watch all the sessions regarding communication system subject, whatever happened earlier and whatever the upcoming sessions are there. So kindly attend so that you will get maximum benefit from these sessions, right? So for the time being, I will stop here. Thank you, everyone.